All right, welcome everyone to our second video in our series for our complex number topic. Now, last time we talked about all the basics, and this is a continuation of some of the more advanced topics for the irrational numbers. So make sure you are following my social media so you don't miss any future videos, and let's dive right in. So last time we did addition, subtraction, and multiplication with irrational numbers. So today we're going to talk about division. How do we divide by these irrational numbers? So first of all, division means we can write it as a fraction where we have the first number divided by the second, so it becomes a fraction. Now, we don't actually want to have those surds or irrational numbers in our denominator. So just by writing them as a fraction is not going to be the final step. Now, what we're going to do, and this is a little bit of a trick if you haven't seen this before, we're going to multiply by a fancy 1. This should come a little bit of no surprise because we do a similar thing when we look at fractions. If you're looking at equivalent fractions like 1/2, 4/8, 6/12, they all have the same kind of ratio, the same kind of idea that they give forward the same value of number, but they all look different. And what we did is we multiplied the numerator and the denominator by the same number, and we just changed the look of our fraction, not the actual value. The same thing is what we're going to do here. So let's have a look at our 1 divided by the square root of 2. Here we're dividing by a rational number, causing our surd, our square root, to be in the denominator. So 1 divided by square root of 2, we don't want that, so we're going to multiply by what we've got in the bottom. And here I have specifically chosen square root 2 divided by square root of 2 as the number that we multiply by. Now clearly those would cancel out, giving us 1, so the only thing we're doing here is multiplying by 1. It just looks a little bit different. Let's see what happens. If we multiply the numerators together and the denominators together, we can see at the bottom, we've got the square root of 2 times the square root of 2. Well, we know how to combine that together from our previous video, and then we see we actually have a perfect square. So at the bottom, we end up with root 2 over 2. Now, 1 divided by square root of 2 is actually the same thing as root 2 divided by 2. Now, the process that we've used here has managed to get the square root sign out of the denominator because here we multiplied by the same thing, causing us to have a perfect square. This is exactly the idea that we're going to be using. So if we do another example with 1 divided by the square root of 3, now in order to get rid of the square root of 3, we would have to multiply the denominator by square root of 3. And hence we need to do the same in the top. Let's have a look what we get here. In the numerator, we can expand and we can multiply the same as the denominator. We put our numbers together, and because we have a perfect square at the bottom, we get 2 divided by 3, and we have our root in the top. Okay, one more example. If we have a number other than 4 in the top, it doesn't matter. We do the same thing. It doesn't matter if we are using algebra, we do the same thing. So we multiply by the square root of x divided by square root of x. Now, what do we have at the top? Well, it's just multiplying the 2 together. That's pretty easy. At the bottom, we see we have a perfect square, so the square root disappears, and we have our new term with no root in the denominator. Okay, but what do we do if we do 1 divided by the square root of 2 plus 1? What do we do now? These ones seem pretty straightforward after I've shown you the first step. Let's have a look what we can do for any of these division by irrational numbers. So this is the question that we're looking for in the beginning. And in order to really understand what we're doing here, we need to use some special expansion formulae. So you should already know them from last year. These are your perfect square formulas. If we have if we have a plus b squared, that actually expands to the first part squared plus 2 times 1 of each plus the last one squared. And the same thing if we have a minus, but the middle term is going to have a -2. If you're not sure on why this happens, do the expanding yourself. A plus b times a plus b, connect all of the parts using the FOIL method, expand, and you will see that the a and the b and a together make up these middle terms. And depending on which sign you have, that is the sign positive or negative for the middle term. However, the one that we're really interested in is the third part, where we have a minus b times a plus b. If you were doing a lot of factorizing in the last couple of years, you would have recognized this to be the difference in squares formula. You would have had to factorize the end part and get what we have in our brackets. Now, the reason why we're so interested in this formula is because there's no middle term. We do recognize, though, that the b at the end, or the b squared, if I want to be precise, will have a negative because of the switch sign in the brackets. So this is the one that we want, and let's have a look how we can use this. Now, here is our question again. If we want to drop some of these square roots, we need to multiply by something that gives us the first component as a square. That would be nice, then the square root would go away. But we can't have a middle term. So we're going to multiply by something that doesn't have a middle term. So we're going to use our formula where we have a minus b times a plus b. So we're going to multiply by the denominator and the numerator by square root of 2 minus 1. Let's have a look what we get. Well, in the top, 1 times the whole numerator, that's an easy step. But for the denominator, we're just going to look at how they are structured. And remember, we have made them into this special formula. So it is important that at this point, you don't expand these each time. It is going to be required that you jump from this step to the next step, because you should be familiar with the difference in square formula. Remember, this is the whole reason why we're doing this with this special formula. So if you expand it, give this a go now, see what happens, and you should get to the point where we have exactly this at the bottom, and you see that the green part and the pink one cancel out. Now, for the future, you should recognize that this is immediately a squared minus b squared, and here the first part squared will be the square root of 2 squared. Well, that's just 2. And 1 squared, that's 1 with a negative in front. All right, so once we have this, you should no longer be required to do this expanding, but if you ever are stuck, you can always go back to the basics. All right, at the bottom, we're just simplifying the last term. 2 minus 1 is divided by 1, so we get our answer as root 2 minus 1. Okay, that was a lot of work, right? There was a lot of things that we needed to do. So let's make it a little bit easier and compact using that formula. So here we're going to have 2 divided by the square root of 3 plus 1. Now, we're going to have our a and b values, and we're going to multiply by the same thing, but we're going to switch the sign because we want to do a minus b times a plus b. So here in the yellow, that's the only thing you need to do. You just switch the sign between the square root and the number and multiply the denominator and the numerator by the same thing. Then the numerator is a bit of expanding work, and the denominator, we immediately know it's the first part squared minus the second one squared. The first one squared becomes 3 because the square roots cancel. The second one is 1 squared is 1. And we can immediately write down our answer as 2 times square root of 3 minus 1 divided by 2. Now you could have expanded the top, but here I already saw that the denominator was going to be 2, so now we can just cancel them out. Okay, give this one a go. What do we have to multiply this one by? Well, in the denominator, we have a square root of 3 plus the square root of 2. So we're going to just switch the sign to square root of 3 minus square root of 2. And then we're going to multiply by that in the numerator and the denominator. And I'm not even going to write it at the bottom anymore because I know that the denominator is just going to take the first value, which is square root of 3 squared, and the second value, which is square root of 2 squared, which will give us 2. So we're just going to end up with 3 minus 2. In the numerator, however, I still have to make sure I expand because those will now cancel out. So doing some expanding in the top will give us this whole expression. And again, you know how to simplify these. Square root of 3 and square root of 3 and square root of 3 is a perfect square. It's going to work out to be 3. And you will see, I'm pretty sure you get to this answer over here. Okay, next example. What will we do here? Well, again, the rule is clear. We just check the denominator. What is the sign in the denominator? Switch the sign, and whatever you've got, you multiply by the top and the bottom. And the bottom, you don't even need to, oh, excuse me, that should not be a times, that should be an equal sign in between. So we're going to say the first part is equal to the second. We're just going to evaluate the bottom part and evaluate the top part by expanding. And we're going to get to 8 minus 3 in the bottom because it's the first component squared minus the second component squared. Awesome. Okay, simplifying just like we had before. And now there's just one last thing. The reason why we are doing all this work is because we want to write this in the form that we have defined our irrational numbers. This number over here still is a fraction. So what we're going to do, once we have eliminated the square roots in the denominator, we can take separate approaches at taking these apart. So we're going to separate our fraction. The first part is going to be 2 root 6 divided by 5. The second part is going to be 3 over 5 and a negative in front. So if we look at that over here, we can separate it, and this is usually required for most of your questions in the exam. They will say, put your answer in this form, and you have to get rid of the denominator if they have square roots, and then separate the fraction so that it is exactly in that form. Here it doesn't really matter actually. I just wanted to make sure here we have the a in front. So in our answer before we had the minus 3 over 5 at the end. That doesn't quite matter, but if you want to be very precise, you can put it exactly into this form so it matches. Awesome. Now, once we have now figured out what to do and how to get rid of the denominator properly, we can actually define our rule. And what we did is we used something called the conjugate. So the conjugate of a plus b times the square root of c is formed by switching the sign between the terms. So a plus b times square root of c becomes a minus b times the square root of c. This is exactly what we were doing, and the concept of conjugate will be very important, not just to the irrational numbers, but also in our complex numbers. So make sure that you are aware on how this works and what it actually does. So what are the conjugates of the following? 3 plus 2 square root of 3. Well, remember, we just switched the sign. That's an easy one. 3 minus 2 square root of 3. Well, I'm sure you can do this one. What would this one be? Yeah, so we switched the negative to a plus. Very good. Now let's have a look at another example. What about if there's just a square root of 3? Well, think of this as 0 plus the square root of 3. So we're going to make this a negative, or, and here's the thing, you don't even need to here. The reason why you don't necessarily need here is because of what we saw in the beginning. We don't care if there's a negative or not for multiplying the top and bottom, because if you think back at our first examples, we got rid of the denominator because they just square together. But if you want the proper conjugate, make a negative in front. The last one over here, we have the square root of 5 minus 2. Well, we again switch the sign and we've got it. So our last rule is going to be dividing by an irrational number. We'll need to follow 2 steps. We first have to rationalize the denominator, which means we multiply the top and the bottom by our conjugate. Then we're splitting our fraction so that we get the form a square root of b plus c. Awesome. This is it for the second video of this course. Remember, I have a fully structured course for majority of our concepts. So make sure you check out the first link in the description so that you can follow all of the videos in order and you can log in, save your progress, and make sure that you have a look at our premium services. So we have practice examples, we have rules that you can use as flashcards, all the rules that I've been talking about. Make sure that you're learning those. And if you need help, use some of our tools. They will help you along the way. Awesome. Thank you very much. And I will see you in the next video of part 3.